Hello and welcome to Strictly Geothermal, the official podcast of the National Geothermal Centre, a place where we give geothermal insights, expertise and opinion. I'm Matt Killeya, I'm an entrepreneur and campaigner and a lover of all things geothermal.
Hello, and I'm Charlotte Adams. I'm the CEO of the National Geothermal Centre and I'm a hydrologist, so I'm into rocks and water.
That's great. And so this is our first episode. Thank you so much for listening in. We're sort of learning as we go at the moment. But the idea behind this podcast is to excite and educate and engage people on geothermal and sort of spread the word, I guess, about the huge potential that geothermal has for the UK. So to set the scene before we get into the detail on geothermal, let's take a step back and think about some of the wider context. So today I want to focus on one of the main events happening in the world right now, which is the ongoing war in Iran. Now, the premise to this podcast episode, and it will be the same with many of our episodes, is that the UK faces a huge problem, and moreover that geothermal can be a significant part of the solution. And so the problem we're focusing on today is energy insecurity. And that, by the way, is not a UK specific problem. It's one faced by many countries around the world. So turning to Iran, it's just over a month since the war started with US and Israel strikes on Iran and then retaliatory strikes from Iran against Israel and other Gulf states. It's obviously a human tragedy with thousands killed and injured already and many more displaced. In terms of how that's felt in the UK, one of the main ways is in terms of disruption to our energy supply. So we all know that geopolitical events in the Middle East can often lead to increases in the price of things like gas and oil. In fact, both of those are up over 50% since the start of this war. But in particular, we've seen the weaponization by both sides of energy infrastructure. So ballistic missiles and drone attacks on oil refineries and other energy infrastructure. So one example is the gas fields in Qatar, which were struck by Iran, and Qatar Energy reported that 17% of gas production would be disrupted for 5 years as a result. So talk about huge disruptions here. The other example is the Strait of Hormuz, which is a narrow strait of sea between Iran and Oman. So 20% of the world's liquefied natural gas, or LNG, and 20% of the world's seaborne oil trade pass through that strait, or they did. It's now effectively closed. There's very little traffic passing through that strait. So why does this matter for the UK? It's because we depend on imports and because the price of gas and oil are set globally. So the oil is mainly used in the UK for the petrol in our cars and other transportation. And also gas, we use the vast majority of us to heat our homes and heat the hot water and for cooking. We also use it in the UK for generating power. It's about a quarter of our power is still generated using gas. And then there are other things too. So like industrial processes for steel and glass production and agriculture is another big one. Natural gas is a raw material for fertilizer. So now we're talking about food production. So all this leads to price rises. That's the cost of petrol at the pump, the cost of our gas bills for heating our home, and food prices. And also, the threat leads to the threat of things like the potential for fuel rationing or power blackouts and so on. Now, of course, it's not the first time that we've seen or felt these kind of effects. In fact, it's sort of been a repeating pattern through the last few decades at least. Most recently through events in Ukraine, back through the two Gulf Wars, back through the Iran-Iraq war, and things like the Suez crisis as well. So this is a huge problem, huge weakness for the UK and the UK economy. That's a big problem for the UK government, and that's a big problem for all of us. So there it is. That's the problem. We're seeing it play out once again, as we have before, with events in Iran. And the question is, well, what is the solution? And specifically here today, how can geothermal help solve this problem? So Charlotte, so I've just outlined there some of the events that are happening in the Middle East and their impacts on oil and gas, and so that brings us very naturally onto energy security and in particular geothermal. So let's start by talking about what does geothermal offer us in terms of energy security.
So in terms of geothermal, it's quite widely deployable in the UK. A lot of people think you need to have volcanoes to have geothermal energy, but we've proved in the UK that you don't. And we've got a lot of different types of resources spread across the different types of geology that we have. So in most places, you have access to geothermal. And we now have projects that demonstrate most types of those deployments that you can have as well. So for example, there's projects in Cornwall that produce electricity, one in Southampton that's been producing heat since the 1980s, a project that's using mines in Gateshead that's also been producing heat now for the past 3 years. And we've got lots of other exemplars as well, but those are some of the key ones. And the thing that geothermal offers in terms of energy security is it allows us to take back the control of our energy supplies, particularly for providing low carbon and securely priced heat for homes and businesses, which is still a key challenge for the UK.
Okay, that's really interesting. So geothermal is obviously has potential in the UK. So you listed there projects that go from extracting warm water from close to the surface all the way down to drilling very deep, I think, and essentially extracting steam to generate electricity. So it's clear that we can use geothermal to produce heat and power in the UK. We're already doing that. In terms of the energy security piece, though, I mean, geothermal is currently a very small part of the mix. So what does our energy supply look like at the moment, and where is the insecurity specifically in the UK?
Yeah, so it's a good question, and focusing on our gas supply because that's where a lot of our energy comes from, and that energy has yet to be decarbonised or replaced with a renewable alternative. But currently we get around about 40% of our gas from the UK, so that's our own offshore producing gas fields. However, they are in decline, so in the next decade or so we can expect those to be going out of production. We get a similar amount, so another 40% via a pipeline, predominantly from a single gas field in Norway. So as you can imagine, that is a single point of vulnerability and a heavy reliance. And then we get around about 20% of our gas as LNG, which is then compressed and shipped from various places around the world, places, as far afield as Angola, and people perhaps don't realise they might be frying their bacon in the morning on gas that's come from somewhere as far afield as Peru. So that is our most carbon intense form of gas because it has to be compressed and then it's got a long travel distance, but it's also really expensive. And we currently pay between 5 and 20 billion a year for our gas supplies in a fairly normal quiescent year. But when you've got kind of geopolitical shocks taking place, such as is happening currently, and such as we saw in 2022 when we had the invasion of Ukraine, we saw that the annual gas spend for our imports, so that's just the gas we're getting down the pipeline from Norway and as LNG, was 50 billion. So that's quite a significant cost, and indications show that we're back at those levels now that we were in 2022. And every 10 years or so, we've seen a geopolitical shock that has done this to our energy prices. So it does leave us in an insecure position because of the reliance we have on other nations. And also internally to the UK, we've got rid of a lot of our gas storage now. So we don't have the facility to store gas within the UK at periods of high demand or at periods where supply is challenged, such as external events. We want to think about how long we want to keep rolling the dice and leaving things to chance, or take back some control by developing our geothermal resources to provide heat and, in some cases, power.
So we're talking about huge amounts of money that we're spending on importing things like LNG, and this also seems to be quite variable, quite volatile. So we could be spending a few billion one year, but then when there's a crisis, as you said, suddenly those costs can really spiral quite quickly. Is that right?
Yeah, I mean, we're seeing the costs increase when there is a geopolitical event, maybe by 5 or 10 times. So it is a significant cost. Of that 50 billion we spent on gas imports during 2022, half of that, so 24 billion, was on LNG. And as well as being expensive, it's also our most carbon intense form of gas.
Yeah.
So of that gas that we burn, it's responsible for 60% of our emissions from burning gas, yet it's only between 16 and 20% of our actual supply of gas. So it's got a lot of carbon footprint associated with it, as well as a lot of cost.
And so, in terms of that, every time there's a geopolitical crisis, it then costs us a lot of money to import gas, and then that money is just sort of spent, isn't it? So rather than being invested in the UK, it's just a cost that goes to the treasury, basically.
Yeah, and that's an opportunity, to offset that, really, because the actual volume of heat that we're effectively buying in, or the volume of energy we're buying in the form of LNG, that amount aligns quite well with what is available from geothermal in the UK. So you could argue that there's a really strong case for replacing that LNG we're buying in now with our own geothermal resources. If we act now, we could do that relatively quickly. I think it would be more cost effective, and there's also knock-on benefits from that, such as where the heat is used, because heat doesn't travel that well. There's opportunities locally for economic improvement and business opportunities. There's also opportunities for job creation as well around that, with new businesses and new industries forming.
Yeah. So I want to come on to that in a second, but I'm just finally on this piece. So we've talked a lot about the kind of increasing cost whenever we have these geopolitical events. But presumably things could get worse than that with our external dependence. So at some point, presumably we wouldn't be able to get enough gas into the country potentially. So therefore, we're talking about things like moving to a 3 or 4 day week. This kind of thing is that something that's feasible?
Yeah, conceivably, gas supplies are reducing. As I mentioned previously, the continental shelf will decline and probably even cease to produce maybe in the next 10 to 15 years. The Ormen Lange gas field, where we get our imports via the pipeline gas, that is also declining in production. And though they haven't set an end date for that, we think probably within the next 20, 25 years that will also be declining. There's other large gas fields in Europe that we could tap into, but there's more competition from other EU states for using that. The LNG is not in decline. In fact, last year there was something like a 4% increase in LNG output in the first half of the year, but it is again under increasing competition from other nations. So we would have to fight harder and potentially pay more for our gas supplies in future, or risk not having enough. And I think in terms of the blackouts and things like that, I think the biggest challenge is keeping the heating on, and not having that storage within the UK, I think also leaves us quite vulnerable.
Yeah, so we're basically, to summarise, we've got quite a fragile energy system with a considerable number of external dependencies, which at various times can become very expensive or unreliable in terms of giving us the supply that we need. So let's then move to geothermal. So I think that the first thing is just on geothermal. It's obviously a low carbon source of heat and potentially power from the heat in the ground below our feet. I think when people hear about renewable, one thing they sort of worry about is the sort of seasonal nature of renewable energy, like wind and solar. The fact that you can't always rely on supply. Is that something that geothermal is better or stronger at?
Yeah, geothermal doesn't have the variability with it that some of the other low carbon technologies do. So it could be very valuable as a base load solution. It's quite controllable. You can turn it off and on as you want. You can increase output or decrease output as you want. All it involves is changing the flow of water, which is the energy carrier, bringing the energy from the bottom of your borehole or well that you're getting the fluid from up to the surface where you recover the energy. So there's a lot of flexibility in it, and there's opportunities alongside it in some geothermal systems also for cooling, for thermal storage, and in some instances for recovery of other minerals such as lithium from the geothermal brines that you're producing too. So there's lots of advantages to using it.
Yeah, and in terms of that resilience, so you're basically saying the heat is just always there in the ground, essentially. So it doesn't have that sort of seasonal component to it.
And we've got quite a few technologies that produce electricity. So you've mentioned wind and solar, but geothermal in the UK, although it can produce electricity, as we've seen at United Downs in Cornwall, where geothermal electricity has just been switched on for the first time, its resource and the temperature of the resource we have is much better suited to heat. And we don't have a lot of alternatives at the moment. Hydrogen is not as technology ready as geothermal is. So geothermal does present a continuous and technology ready low carb solution that we can develop and take back more control as well.
Yeah. Okay. So it's really the heat part of the story where the UK is very much behind in terms of decarbonising. And as you just said, we're talking about a technology which is sort of ready to go. It's already been developed and deployed in other European countries that have sort of similar geology to the UK. Is that right?
Yeah, and if you look at some of those other countries, there's things that we're looking at the National Geothermal Centre that, how has that worked in that country? And what learnings do we need to bring from here and back to here for how we make it work in the UK? And one of the things as well is the kind of cultural practices and ways in which heat is used. So, for example, in Denmark, 60% of heat will go through a heat network. And people are used to being on a heat network. Their homes are all connected to other homes. They share heat effectively. In the UK, we're less used to doing that. We only have 2 to 3% of our heat going through a heat network now. Yet the government wants to increase that to 20% by 2050. And that's a huge opportunity for geothermal because it can be plugged in effectively to a district heat network, as has happened in the Gateshead scheme, in order to provide low carbon heat going forwards.
Okay, so just in terms of explaining to our listeners what a heat network is, so we're not talking about each house having an individual gas boiler, but now we're talking rather about a network of hot water, of pipes with hot water and connected to a heat input, and that potentially could be a geothermal heat input.
Yeah, and because geothermal, the upfront parts of geothermal are a bit more costly until you've got the borehole into the ground and you've proved the amount of resource you can get out from it. It can be more costly than other heat equivalents. And so there is an argument for doing it at scale. It is possible to do it on a range of scales. You could put one borehole in to feed one house, but it makes sense to scale that up. So in order to do that, you need a heat network. So you would have a network of several homes, several hundred homes or 1,000 homes, depending on the scale of that. You'd maybe have some big energy users connected to that, which we call anchor loads, which are key to keep the system running and to make maximum use of the asset you've got underground. So that anchor load could be a hospital or a prison or council offices or a school, something like that. And it's, as with all these kind of energy systems, it's really good to have a mix of users that are calling for heat at different times of the day. But they're all effectively connected on a similar network and in their homes instead of having a gas boiler. So then you're removing the risk of carbon monoxide and all those things associated with burning gas in the home. You've got a thing called a heat exchanger, which is able to take the heat from the network and transmit it around your home, and also working in reverse if you've got cooling as well.
Yeah, so you mentioned hospitals there. So that's sort of a really interesting example, isn't it? Because presumably they have very large heating and cooling requirements. Are they also need a continuous supply, don't they? In terms of energy resilience, I would think hospital is very much dependent on being able to have uninterrupted supply. So is that really a great example of somewhere that could really benefit from a geothermal scheme?
Yeah, I think it's a really good example because, as you've mentioned, it has those high heat demands. So, in terms of the economics of a geothermal scheme that's supplying a hospital, you've got high hours of use, which you're getting more as the operator of that scheme. You're getting paid more for running the scheme. You're satisfying the demands that the hospital has, and obviously that need to have constant supply. It might mean you design the scheme slightly differently to make sure you've got that backup in there. So you might have two boreholes to supply the energy from rather than one, so that if something happens to one of them, you've got, or you need to maintain the pumps or something that are in the borehole, you've got that flexibility. But hospitals are a really good example because of their high energy use and special requirements, and also because people use them as well. So from an awareness raising point of view, I think to be able to have some signage up in that hospital saying, this is heated from the earth and it's a really low carbon system is also a really good way to improve the visibility and improve the acceptance and demand for geothermal across the UK.
Yeah, that's really interesting. And I want to pick up on something else you said earlier. So you were talking about, I think, like local delivery benefits. So things like local government and particularly in terms of energy resilience. So we've already established that the UK energy supply is quite fragile and dependent on, you mentioned, for example, the single pipeline of gas to Norway. So is there really a strength here? Is there really a sort of synergy with local government and building sort of schemes locally to build a more using geothermal to build a more resilient energy infrastructure?
Yeah, I think there's huge potential for local government to lead the way with this, and indeed many of them are. So they have been able to access funding, public sector decarbonisation funds, which sadly has ended now, but that has enabled local authorities to access funding for heat network and low carbon energy projects. And also the Green Heat Network Fund as well has also been accessed by local authorities. That is now open to non-local authorities too. But certainly using the example at Gateshead, they accessed that type of funding in order to make their scheme work. And that enables them to sell heat to their customers at 5% less than they would be paying for gas. So that's had an impact on people's lives. It means that, for example, someone who previously had an electric shower in their home now has a home shower that's connected to the heat network, and that's much cheaper for them to use now because they're not paying the electricity price for it. They're paying a much cheaper price than they were.
So the Gateshead scheme, which is the largest geothermal scheme in the UK, is a council-led scheme, isn't it?
Yeah, so that was led by Gateshead Council, and it's using the historically abandoned coal mines beneath the site as the energy source. So water with them at 16 degrees is boosted by a heat pump and fed round the heat network to a wide range of kind of municipal customers, businesses, homes as well, and also some kind of public spaces. So the Sage and the Baltic Art Gallery are both on that system. So it's a real exemplar of what can be done, and people who are paying for the energy on that scheme, that money they're spending is staying within that town and that region and used for improvements across the borough, which is a really interesting model rather than everybody paying money to the big six or the equivalent, and it leaves perhaps the area where you are. So heat and geothermal does allow opportunities for local economic improvements.
Yeah, okay. And obviously those councils, we're talking about councils that often own and manage large buildings and estates, and many of them have big council housing stock as well. So this is the kind of thing that a council could join up with a heat network and potentially use geothermal to feed into.
Yeah, and there's quite a lot of councils looking at it now, and there's certainly potential to look at the heat networks that exist already. We don't have many, but we have some. So Gateshead was an example of a retrofit and an expansion of a geothermal scheme to an existing heat network. But local authorities, I think, have the opportunity to lead by example. It might make it easier for them to negotiate with the people who will buy the heat, because that's always the challenge, guaranteeing you're going to have that market before you spend the money on the infrastructure that's required. And often they own the land that's required for the heat network and for the geothermal plant and for the energy centre, which doesn't have to be a big building at all. And the boreholes are all kind of effectively covered in manholes, so they have a very low footprint, but they still do require to be sited somewhere. And if the council has land, that's a real opportunity. And at Gateshead, their scheme, they had a solar farm there as well, which is on what might be development land in future, but that solar farm can be dismantled if needed. But in the meantime, it's helping to run the electricity required for the heat pump that's heating the water in the heat network, and also the pumps that are getting the water out of the ground. And at times of lower heat demand, it's a carbon neutral scheme, so it's a really good exemplar.
That's really interesting. And so in my home city of Sheffield, we've already got two heat networks. So one uses an incinerator to generate the heat that goes to heat the water in the pipes, and the other is a biomass plant. So in these kind of situations, it's possible to switch out the heat input potentially and connect to a low carbon geothermal input and use the same heat network.
Yeah, it's a good thing about heat networks. I mean, you do have to bear in mind of the temperature they're designed to run at and the temperature of the sources you're feeding into it. But there's no reason why you can't have a heat network that's maybe started off as a biomass one, or it may have had a waste heat feed originally. It may have a geothermal one added later. So they are really interchangeable in terms of the energy source you can feed into them, which is one of their key advantages, I think.
Okay, councils in the UK are famously cash strapped at the moment. So I'm just wondering, in terms of support from national government and national policy, are there things happening, or are there things that need to happen that could really help councils develop those kind of plans further?
I think the Green Heat Network Fund is a really good step, because that is accessible for putting in the infrastructure. And I think if you were to do a geothermal scheme as part of that, some of the drilling that is required up front, maybe your first borehole for the scheme, would be covered by that, which is quite a key thing, because until you've drilled something, you don't know exactly what you're going to get out of the ground. So if that initial unknown can be covered as part of that scheme, your subsequent boreholes should be easier to find alternative investment for, because you kind of know what's down there having drilled the first one. Yeah. So I think that's really important. I think the removal of the public sector decarbonisation scheme is a shame. It's probably removed a bit too early. I think that led to a lot of projects. And I think that we are seeing a decline in the number of local authorities doing some of these projects, because that source of funding has been removed. For geothermal specific projects, if we had a risk insurance scheme to cover the initial risks involved in drilling and proving the borehole supply, that could be a game changer for geothermal more widely, but also for the local authorities to do it. And I think it's also them having the capacity in-house. Some local authorities are bigger than others. They may not have engineers or groundworks people that can, that have the skills set. So I think it's important that government supports them. And I know that some of the MPs we're working with are looking at ways to support local authorities with that kind of knowledge and understanding to deploy their low carbon energy projects, which include geothermal as well.
Yeah, okay. So then, final point to discuss in our first podcast, you touched on the sort of economic benefits of building these things locally. And I'm just curious about jobs and skills. And it seems like there's a real opportunity there in terms of construction and engineering and other jobs as well. So is this really a big feature and strength and something that's really appealing about expansion of geothermal?
Yeah, the job potential, I think, is really important. We have looked, as I've mentioned before, in terms of what the geothermal potential could be for the UK, and we based that on looking at what Germany has done and France have done and the Netherlands have done, because they've got similar geology to us, similar energy mix, similar climate, those kind of things are similar. And And we've seen, particularly in the German example, that for every megawatt of project in the ground, that creates between 5 and 10 jobs. So we see that as an opportunity. So, for example, the Gateshead project runs at 6 megawatts, so that's up to 60 direct jobs could be created through that scheme. And then obviously there's indirect jobs associated around putting the heat network and things into the ground. And we've got the oil and gas sector in northeast Scotland, and also there's parts of the supply chain in other parts of the UK as well. And within that, not only is there a huge skills and knowledge and experience base that we need to use, we also need to preserve that, because that industry is declining. There's around about 130,000 people working in that industry at the moment, but we're losing them week on week. And they may be going off to other countries or maybe moving into other sectors, but there's a real opportunity to avoid that decline in jobs that we saw perhaps when the coal mines were abandoned, and the impact that had on certain regions of the UK. We've got an opportunity to transition that workforce for low carbon energy, including geothermal, going forwards.
So that's really interesting. We'll have to do a whole another episode on that very topic. But we're talking about a whole UK industry of geologists and drillers and engineers and construction, all these kind of things. Very highly skilled jobs, presumably, lots of those.
Yeah, I mean, there's a mix across the kind of job spectrum. So a lot of those jobs will be kind of require vocational skills. Probably the majority will, but then there's also, kind of project management, geologists, as you've outlined, engineers. So there's kind of degree level jobs required as well. And it's important at the National Geothermal Centre, we're working with the academic community as well, because some of the courses, for example, in geoscience, are being removed from what universities are offering. I think some of them have been linked with oil and gas before, and students don't see that as a new opportunity or a long-term job. So I think we need to reframe some of the training that we're offering as, a geoenergy career, and we're still going to need people in the oil and gas sector until it's declined. So we still need new people going into that, but they need to believe that when the time comes, they can transfer those skills. And that gives us an exportable product as well. The UK could lead with some of the knowledge and experience that it has. And there's quite a lot of companies up in the Scottish supply chain working on geothermal, round about 300 or so. But unfortunately, at the moment, none of them are working in the UK. So that needs to change as well.
Okay, so that's it for our first episode. Thank you, Charlotte. Hopefully you've all enjoyed it as much as we have, and hopefully we've convinced you of the huge potential for geothermal in the UK to deal with some of the fragility and costs in our energy infrastructure by tapping into that valuable resource of heat that is beneath our feet. So thank you for listening. We'll see you next time when we'll be discussing another aspect of geothermal and how we can use geothermal to make the world a better place. You've been listening to me, Matt Killeya.
And me, Charlotte Adams.
Strictly Geothermal is the official podcast of the National Geothermal Centre. The Centre aims to accelerate understanding and uptake of geothermal energy in the UK. Follow us on our web pages or at LinkedIn.